Most people call all mean averages statistics, but this is inaccurate. If we include every score from an entire population and then calculate the mean or the median or the standard deviation, those numerical values are all parameters. For a mean average to be merely a statistic, it must be the mean of only a sample from a larger population. Here's the definitions for a parameter in a statistic. We represent a population mean with the Greek letter mu and the population standard deviation with the lowercase Greek letter sigma. X bar is a sample mean and S is a sample standard deviation. Recognizing whether a numerical descriptor, characteristic, is a statistic or a parameter is extremely important in the study of statistics. Do not take this for granted. If you do not grasp this concept early, it may confuse you later when we begin the study of inferential statistics. Suppose that we were told that the mean salary for all human resources managers nationwide is $71,450 with this standard deviation. These sound to most people like statistics, but since we were told that these were for the entire population, these are actually parameters. Suppose instead that a random sample of 50 human resources managers was taken nationwide, and the mean and standard deviation were 68,640 and 13,290 respectively. These are statistics because they came from a sample. Remember it this way, parameters come from an entire population. Statistics come from samples within the desired population. The study of statistics, this branch of math, involves using good random samples and the statistics calculated from them to determine estimates of unknown population parameters. Perhaps we want to know the average monthly car payment for persons who purchased a car last year. The true unknown mean monthly car payment is the parameter. It would be too costly and time-consuming to determine all car payments and find the mean of them, the parameter, so instead we take a good random sample of perhaps 200 car payments, add them up, and calculate the mean. This mean is a statistic, and it should be reasonably close to the population mean. Our sample mean is considered a point estimator of the unknown parameter. There will be more parameters and statistics to learn later, but let's make sure we can wrap our brains around this now. Choose the correct symbol corresponding to the numerical characteristic described. The standard deviation of words in a sample of headline news stories is 155. This would be S. This is a statistic. It came from a sample. The mean hours of work per week by restaurant managers in California is 48. Somehow all of these were obtained and a mean reported. This is the population parameter, the population mean, mu. The mean years of experience of a sample of recently hired mechanical engineers is 8.8 years. This is the mean of only a sample of recently hired engineers, therefore this is X bar, a statistic. The trickiest type problem might be like this. We found the mean and standard deviation of 30 test scores in a recent math test. Would these values be parameters or statistics? Well, this depends. If these 30 scores were from everyone in a second-hour math class, then the 30 scores represent an entire population. Therefore, the mean and standard deviation would both be parameters. If instead it was a sample of 30 math scores taken from all math classes at the school, then the mean and standard deviation would be statistics. They were numerical characteristics of sample data.